So for solving exponential equations, like I said, there's two ways to do it. We can change the base, get common bases, or we could use logarithms. But we don't know how to use logarithms yet. So if we just look at one like the one that we did to start with, which was 3 to the x equals 9, and you said x equals 2, really what the method works like this. 3 to the x, and then you take 9 and make the base the same. So 9 is 3 to the power of 2. And once you have the bases the same, you can just drop the bases. 3 to the power of x is equal to 3 to the power of 2. Anna's the only one that got it. X equals 2. Okay. So here, the bases are 2 and 4. We can change those both into the same thing. What would that thing be? A 2. We're going to change them both into 2's. So the first one's already a 2. We'll leave it as is, 2 to the power of 4x. But the 4 can change into 2 to the power of 2. And I'm just going to write it like this for now. So it's 2 to the power of 2 to the power of x plus 3. So get the bases the same. That's the first step. And you usually can look at what is the smallest base and change them all into that. So the smallest base originally was 2. We changed the bases to 2. Now I'm going to expand the exponents. So 2 to the power of 4x is equal to 2 to the power of 2x plus 6. You need to do that step before you drop the base, because you have to use the laws of exponents, and if you don't use the laws of exponents, it's not going to work. So get the bases the same, and then expand and simplify until the point where you have one exponent on each side, one base with one exponent. So not a power of a power or two bases multiplied together or anything, just like this. Now we can say 4x equals 2x plus 6. The bases are gone because they were the same. And now this you know how to solve, right? Because it's just a linear equation. So subtract 2x from both sides, 2x equals 6. Then divide by 2, x equals 3. This one's a little bit trickier because the base is not easy necessarily to find, and you really have to know your exponent laws here. I'm going to change them both to a base 9 over 4. Sorry, no I'm not. I'm going to change it to a 3 over 2. I'm looking at the 9 over 4 and the 8 over 27, and those don't really seem to correspond to anything to me, but if I change it like this, 9 over 4 to the x minus 4 equals 27 over 8 to the 2x, to the negative 2x. So I made the exponent negative just by flipping that one over, right? That's one of the exponent laws. When you take the reciprocal of the base, the exponent becomes negative. Now I can see similarities between 9 over 4 and 27 over 8, because both of them are 3 over 2 to some power. 9 over 4 is 3 over 2 squared. And how about 27 over 8? 3 over 2 to the power of 3. Once you change those, then expand. So this becomes 3 over 2 to the power of 2x minus 8 equals 3 over 2 to the power of negative 6x. So just multiplying those exponents. And then it's easy. Get rid of the bases. 2x minus 8 equals negative 6x. And solve that for x. So usually once you get the bases the same and the exponents simplified, it's fairly easy. That's just another linear equation to solve. I'm going to subtract 2x from both sides. I'll take it up here where you can see it. So it's negative 8 equals negative 8x. Right, subtracting 2x. And then divide by negative 8, so x equals 1. Again, you can check by filling the 1 in the place of x and seeing if both sides of that equation are equal. Okay, this one has 3 powers. But what base could we change them all to? A 2. 16 is 2 to the power of what? 4? So we'll change that to 2 to the power of 4 to the power of 3x. This is already a 2 to the power of 5x plus 2. So we'll leave that. And 8 is 2 to the power of 3, right? This is where it becomes really important that you do all the expanding and simplifying first. This will become 2 to the power of 12x, 2 to the power of 5x plus 2, times 2 to the power of 6x. You can't get rid of the basis yet. You only do it when you have 1 power on each side. And here we have 2 powers on the right. So we need to multiply them together. And what do you do with the exponents when you multiply powers with the same base? Add the exponents. So that's why it's so important that you get it to that point where it's just 1 power on each side. Because if you got rid of the bases now, you'd think you'd have to multiply 5x plus 2 times 6x, but you don't. You add them. So this is 2 to the power of 12x equals 2 to the power of 11x plus 2. Add the exponents. Now I can get rid of the 2's, so I have 12x is equal to 11x plus 2. So what's x equal? 2. Subtract 11x from both sides and you get x equals 2. Oh. 5 to the power of x equals 125 root 5. How many powers do we have here? 3, yeah. And what are we going to change them all to? Base 5. So 5 to the power of x will just stay as 5 to the power of x. What's 125 as a base 5? 5 to the power of 3. And if you don't know, just use your calculator. Go 5 to the power of 2, 5 to the power of 3, 5 to the power of 4, whatever. Guess at what you think it is and check on your calculator. What about root 5? 5 to the power of 1/2, right? Why is it 1/2? It's the rational exponents law, and it looks like this. Let's see. A to the power of m over n is equal to the nth root of a to the m. That's the rational exponents law. So this has an index of 2 and an exponent of 1 on the 5. So right in here, there's a 2 and a 1 that you can't see, so that's where the 1/2 comes from. So then 5 to the power of x is equal to, add the exponents, 3.5, 3.5, 7 over 2, whatever you want to call it, and then just get rid of the bases. X is equal to 3.5.